the way I chose to split this up was right here and right here only, because I saw that trapezoid. A lot of you probably also split it like right there. Is that true? Either way, I've got 40 square inches here. And right here I got 10 by 10, so 100 square inches here. And then the trapezoid, I'm going to write over here. Remember, the area of a trapezoid is 1/2, so I'm averaging the bases. So I had a base of 2 and a base of 10 for that trapezoid. And then this distance between the bases is the height, that's 18. So half of 12 is 6. 6 times 18 is 60 plus 48, 108. So if you split that into two figures, you just would need your triangle and your rectangle to equal 108. Here's the reason why I want this. If I could fill in this whole side, that area, right, and then multiply it by the height, that fills in the whole thing. So I had 248 times the 20. I'm filling it in that way from that front base. Okay, and 248 times 20 is 4,960 cubic inches. Now, all the other classes today as well, some people found they found the volume of this, the volume of this, and the volume of all this, and then added it together. That would also work. It's the same thing. What I chose to do is try to do this visual with me. I'm going to try to grab a different color. I try to say I have all of this, and I have it once, and then I have it over and over for 20 inches to fill it in. Can you kind of get that visual? So that makes our equation we've been messing with volume, area of the base times the height. That's I like the visual. That's how I have it memorized in my head. The math is doing that. Now, out of curiosity, did anybody try to just find every other face and then add them up for surface area? No. Yeah, I'm going to let you know that's going to be the tougher way. So. I'm going to do it, and then I'm going to give you the visual why it works. So the equation for this, and let's actually get us some more space to write down here. The equation for this is surface area is equal to the two bases, right, the front and back, plus the perimeter of the base times the height. Let me try to explain what the perimeter of the base does. The visual. Really, when you find the perimeter of the base, it's like you're outlining just the outline of the base, right? Can you guys imagine that? Just the outside. And then, if you multiply that outside that direction, just the outside, right? It fills in all that outside area. There's no backside, just around it. Then you don't have to add up all those spaces. Do you get the visual?
Yes.
Yeah. So, the surface area is the two bases. We already found the bases, right? The base was 248. So I have two of those. Plus the perimeter of a base. Now we got to do some work. So 36, 38, 58, 68, 73, plus 8 is 81, plus 5 is 86. And then the height, remember, we got to make that perimeter go to the other base, times 20. Now, I heard someone saying, man, surface area is a lot of work. And it kind of is, but this is way less work, especially when you get all those spaces. So 2 times 248 plus 86 times 20. I got 2,216 square inches. And just by looking at my units, you know which one's volume and which one's surface area, right? Area is 2-dimensional, volume is 3-dimensional. So checking out this page, we're going to look at number 3 on your guys's. And this isn't geometry, so I'm going to kind of go through this kind of relatively quick with you because this isn't new stuff. We knew that our volume was 4,960 cubic inches, right? And the information we're given, it's 0.8 cents per cubic inch. What's tricky there? That is $0.008. Okay? It gave you units in cents. We need it in dollars. So to get the price of foam, I'm taking 4,960, multiplying by 0.008, and that foam is going to cost us $39.68 for foam. I'm going to write for foam so I know what this is for. Everybody good with that?
That's how much Kieran is spending.
For foam. But we also need the vinyl, okay? And so for the vinyl, what it tells us in that table is, it tells us 75 square inches is 45 cents. I can find a rate for that. I'm going to want money per square inch, right? So I divide my 45 cent by 75 is 0.006, or 0.6 cents per square inch. So what I'll do is I'll take that surface area we just found, 2,216, and I'm going to multiply that by the price per square inch for a total of $13.30 for vinyl. Yeah, it does seem pretty inexpensive, doesn't it? So now if we want to know how much it cost total, I'm just going to add my $39.68 and my $13.30, and I get $52.98 total. It took me 8 hours, and I charge $100 an hour. I'm joking. Maybe there's some labor costs involved, but just materials, we're looking at $52.98. Let me set the stage with this sandbox, okay? All the information's here, but sometimes it's nice to hear it too. It has a hexagon base. Do we know how to find the area of a hexagon yet? No, you'll learn about it in geometry. You need like an app with them and stuff.
Isn't
But
that what we do next year?
yes, hopefully. So the good news is it tells us the area of the base. Right up here.
Well, it's not filled.
But they are filling it. So they're going to fill it with 14 bags of sand. That makes this happen. What you need to do is find out how much sand comes in one bag first. Let's get after it. So for number 1, I know I have 1,146 square inches, right?
Sure.
For the base. I'm going to multiply that by 10 inches to get the volume that is in the pit.
That's 11,460.
Yeah, 11,460 cubic inches. Okay, that's my volume. I know I need to split that up evenly among 14 bags. And that's going to tell me 818.57. But
Andrew, round.
nearest whole. So that's about 819 square inches per bag. Okay? It is 3. It's not square. It's cubic. Thank you, Vinny. Oh, that deleted.
I did not. No, I didn't. I used my math.
Okay, so that's one bag. So for number 2, they want 3 more inches. Well, does my base change for that?
No.
Nope. So I've got 1,146 for my base. I'm only going to go 3 more inches high. 3,438 cubic inches is what is going to get added. Now, if I want to know how many bags, I'm going to divide by the volume per bag. So divide by 819. And that gives me 4.19. But Lowe's isn't going to let you just roll up in there, cut a little hole in the side, and drain out 0.19. So you need to buy 5 bags. Maybe they got a bulk section at Lowe's.
Buy 4.19 bags.
No, you can't do that.
What if you get
All right. Now, we need to have a conversation for this next part, okay? This scale factor of 1.5, you might have touched this last year. A lot of people would think if it's 1.5 times bigger, what would I do with the number of bags I need?
You would multiply.
By 1. That's what you would think, right? I get it. But it's a misconception. And let me show you how I know it's a misconception. Let's say we started with a box that was 2 by 2. What's the volume of, or what's the area of that?
4.
Okay. And if I multiplied 2 by 1.5, I'd have one that's 3 by 3. And what is that?
That would be 9.
9. So 4 times 1.5 isn't 9.
No, it's
4 times 1.5 times 1.5 is 9. So here's the why. Here's the why it's not. Here's why it is 1.5 squared bigger. When we're asking you to scale the area of the base, how many dimensions are changing by 1.5? 2 dimensions, length and width. So since you're scaling 2 dimensions, this relationship in terms of area is 1.5 squared, which is 2.25. Okay? So I'm giving you that. Again, the reason it's not just 1.5 is because there's 2 dimensions it's changing by 1.5. And 1.5 times 1.5 is 2.25. So, here's what we've got to do. We know that we need 4.19 bags, right, for 3 inches. But how is this going to get scaled up? By 1.5 squared.
Which is 2.25.
Which is 2.25, yes. Again, it's because it's in 2 dimensions.
That makes sense.
That requires 9.5 bags, but, well, let's go 9.47. But guess what? That's 10 bags because they don't let you just snag 0.47 bags. So again, we'll do more with that changing dimensions by scale factors. If you only stretched it 1 dimension, it'd be 1.5. But we did 1.5 2 different ways. Why didn't we have to do it the 3rd dimension? Did we fill it 1.5 times more sand higher? Did we increase the height? No, it's still 3 inches, right? So we only changed 2 of the dimensions by 1.5. So if they're selling 6 bags for $19.50, how much is a bag? How could I figure that out?
Well, divided by 6.
$19.50 divided by 6, which gives me $3.25 a bag, right? Now there's 2 answers I would take here. I originally just did 1 answer. I said I was going to do 15 bags at $3.25. That was my original answer. You guys vibe with that?
I vibe with that.
5 for the little one, 10 for the big one, or $48.75. But guess what? All this sand's coming to my playground, right?
Yeah.
I could like dump some bag in one and then in another. So then I went back and I was like, actually, 4.19 plus 9.47. That gave me 13.66, which means how many bags could I get away with? 14 bags at $3.25. I could save myself $3.25. And that'd be $45.50. And again, I would take either one of these on a test, but do you see how I was like, I could use partials. They're all coming to my playground.
Yep.
Right? I don't need just the whole bags from both things. They're both my sand pits. So I would take either one of those answers. Like maybe you just get a little extra sand, throw it near a sibling's bed just to make them sleep uncomfortable for a night. If anybody saw that Dude Perfect, that was one of the worst Wheel Unfortunates. That was one of the worst ones. So to attack this one, it's asking what's the area of the circle. Who can tell me the area of the circle equation? Who's got it on the top of the head? Ivy?
Pi r.
So let's see.
What's that circumference?
That'd be circumference. I'll get you started. You ready? Pi r what?
Square.
Yeah, that's the area. So if the radius is 4, I'm looking at this. Right? So which one of these would match? Would A match?
Well, 4 is the radius.
4 pi, does that work?
Nope.
What about 8 pi?
Yes. Yes, 8 pi.
What's 4 squared, everybody?
16. Well,
16.
so it's not 4 times 2.
4 times 4, so 16 pi. 16 pi. And it's about 16 times 3, right? 16 times 3 is 48. 50 would be a good estimate, right? So if our area is 49 pi, what is the radius? And how do you know? Yeah, Brennan.
7 because 7 to the power of 2 is 4.
Yeah, or square root of 49 is 7. It's also negative 7, but you can't have a negative 7 radius, right? So it's just 7. 2 ways we know. I don't know if you notice, I'm walking around listening to everything all the time. Do you guys notice that?
He's got ears.
Yeah.
Like a buddy.
Okay, so for this first cylinder, we've got this. It tells us our volume's 50 pi, right? So I know on the right side that my radius squared is 25. So I actually like to just do this intermediate step here.
That's what we invented.
Okay, and really the question is, to get to 50, what would that have to be? 2. The height would have to be 2 to get that to be 50. 25 times 2 would give me 50 pi.
Oh, okay.
Are you guys seeing how just this one little step makes that pop a little bit? Yep. So checking this one out, all right, this one I know the height, but I don't know the radius. So if I know the height is 4, one way I like to think about it is I could divide everything by 4. Okay, and that would tell me that 9 pi is equal to r squared pi.
So that means that.
So I need r squared to equal 9, correct?
So that has to be
3.
3. Another way to think of it is I can undo the square of something by taking the square root. So the radius would have to be 3. Number one wrong answer I see for that is 9. Good things are happening for that 9. It's not 9 squared, to be 3 squared to equal the 9. All right?
9.
So for about 3 to 5 minutes, I want you to fill out as much as the table as you can. I want to go over the first column. Now I'll go over the second column with you. Second row, I mean, right here. If the diameter is 12, what's the radius? 6. And if the 6 is the radius, the base is pi times 6 squared, or 36 pi, right?
Okay, we gotta grind on this table.
So if it's 36 pi and I need to get 108 pi, what would the height need to be? I'm multiplying my base, right? My base. I'm going to multiply that by the height to fill it in. So my height would have to be 3. Well, because my base right here had a radius of 6, which means the area of just the base was 36 pi, correct? And I need to multiply that by the height to fill it in to total 108 pi, which means if this part's 36 pi, my height would have to equal 3 to fill it in to be 108 pi, because 36 times 3 is 108. I want you to fill out as much of that table as you can in the next few minutes. So, someone give me one of these you want to look at together. Ivy, which number? So this one right here? Okay. So I went 8 and then I went 4. You good with 4 for the radius? And then 16 pi for the area?
Yes.
So I needed to multiply by something to get to 16 pi. So the height would have to be 1. Because my area of my base, so the bottom circle is 16 pi. So from base, the height would have to be 1 to pump out a volume of 16 pi. Who's got another one they want to look at together? Yeah. Right. Which one? The 20s? Let's do this one. So this one, I went to the 20 here, okay? Are you good with the 100 pi for the area of the base? Now, I needed to multiply this by something to get to 20. And I know 20 is 1/5 of 100. And you could also put 0.2 there. Anybody do 0.2?
No. I did not.
Okay. And then this one, what I did is, I was also at the 100 pi. I know pi is like 3.14. Right? 100 times 3.14 is 314. So this is already 314. Times 1 is 314. Yeah, cool.